we now want to talk about kind of building on what we discussed with linear searches and binary searches, and how a binary search is more efficient as long as our list is sorted than a linear search. There reaches a time in which we would say, while an algorithm would work, it may take an unreasonable amount of time. And I want to kind of talk about what does that mean, and how do I know if an algorithm will take an unreasonable amount of time? So we're going to talk raffles before. So before it was just a simple raffle of, does somebody have the number we're looking for? So this is what's called a pair raffle. And a pair raffle, you're looking for two people whose tickets add up to the winning number. So if I have 100 people in the room and the winning number is 1,000, I'm looking for two people that when I add their ticket numbers, I get 1,000. So if somebody has number 907 and they're partnered with number 93, that would be the winning two tickets. And this is more complicated than a linear search or a binary search, because we have to go around and see, okay, let's compare two numbers, add them, and see if it equals the winning number. And then take two more numbers from the list, add them, see if it equals the winning number. Take two more numbers from the list, add them, see if it equals the winning number. And in terms of, if I have two tickets, there's only one thing to check because there are only two numbers to add together here. If I have 3 tickets, it takes 3 checks. 4 tickets is 6 checks. 5 tickets is 10 checks. 8 tickets, it's 28 checks. In other words, there are 28 different combinations of the 2 tickets I'm adding together. There is an exact formula for this, n squared minus n all divided by 2, but you don't need to know that. What's important here is that you notice this is a polynomial. One of the measures of efficiency, so linear is considered a type of polynomial graph because that's a first degree polynomial. But if I have n squared, n to the third, n to the fourth, n to the fifth, the important thing to remember is, like in algebra, that is a polynomial. But if we change the rules and say, well, it doesn't have to be 2 tickets, it can be any number of tickets that add up to the winning number. So if my winning number is 2,500, if somebody has the ticket 2,500, they automatically win. If I have 2 tickets that add together to 2,500, they win. 3 tickets that add up to 2,500, they win. 4 tickets that add up to 2,500, they win. There's a lot more ways that this could work, because now you're not just checking pairs of tickets that add up to it. I have to check every combination of 1 ticket, 2 tickets, 3 tickets, all the way up to however many total tickets I have sold. And this requires a lot more of checking, because if I have 2 tickets, it requires 3 checks. Each of the individual tickets and the 2 that are added together. 3 tickets take 7 checks. 4 tickets take 15. 5 tickets take 31. There is a formula for this, 2 to the n minus 1. Again, you don't need to know the formula. What's important here is that you notice it's exponential, meaning I have a constant number raised to the nth power. Exponentials grow much, much faster than polynomials do. So polynomials would be considered reasonable. Exponentials are considered unreasonable, because exponentials just grow so much faster. So kind of here's a nice handy chart. Linear, which we talked about already, where we're checking each term individually, that's a type of polynomial that's reasonable. The pair raffle, where it's n squared or n to the third or n to the fourth, that's reasonable. Still takes longer, but reasonable. Even the binary, that's actually considered a logarithm one. That's actually a log base 2 from your algebra and pre-calculus days. That's considered reasonable as well. What's considered unreasonable is anything exponential. So 2 to the n, 3 to the n, 4 to the n are all unreasonable. It means the algorithm works, but it just takes too many steps. It takes too long. So polynomial are bad, but exponential gets unreasonably large extremely quick. So if we look at like 100,000 tickets here, or we're going from 10 up to 100,000, we can see the sorted raffle where we're doing a binary search. So this is a binary search. This is the linear search. This is the polynomial. And this is exponential. 10 tickets. Using binary search is 4 checks. Linear search is 20. Polynomial, or the pair raffle, that's 100. The group raffle, that's 1,024. By the time we get up to 1,000, well, binary, that's 8 checks. Linear, it's 1,000 because it should match how many I have there. The pair raffle's 1,000,000. That's a lot. But 1.07 times 10 to the 301st power is what it would be in the group raffle. That's more checks than there are atoms in the universe. So by the time we get to 100,000 tickets, which for something like the lottery is not large at all, we are way beyond anything reasonable with the group raffle. So reasonable time. Algorithms that are polynomial, meaning constant, linear, squares, cubics, quartics, quintics, etc., or lower, meaning something like a binary search, which has a logarithm. Those are reasonable. Exponential, completely unreasonable. We'll talk about factorial a little bit later, but factorial is that exclamation mark in math, where you'd have like 5 factorial is really 5 times 4 times 3 times 2 times 1. That grows even faster than exponential. So exponentials and factorials, completely unreasonable.